Oh, hello there, and welcome to chemistry. Today we're going to be talking about bonds. Okay, so first thing, covalent and ionic bonds. Covalent bonds are the bonds between two nonmetallic atoms characterized by the sharing of electron pairs, and ionic bonds are those formed from the electrostatic attraction between oppositely charged ions in a chemical compound. It's a mouthful. Some differences you might experience. The melting point of covalent bonds are low, and those of ionic are rather high. Covalent bonds are between two nonmetals, and ionics are between a metal and a nonmetal. A dipole. Okay, so now we're on dipoles now. A dipole is a pair of equal and oppositely charged poles separated by a distance. Type of bonds involved are the dipole-dipole, the ionic dipole, and hydrogen bonds. And you may be wondering how this is related to electron negativity. Well, you see, in every bond, there's not always an equal sharing, just like in relationships. So, one atom is going to be much more electron negative than the other, and that one's going to hoard the electrons more. So that'll affect the polarity of the dipole.
An electron group geometry is determined by the number of electron groups. It also depends on the number of lone pairs. When lone pairs are present, the letter EX is added. The X represents the number of the lone pairs present in the molecule. For example, a molecule with two bond pairs and two lone pairs would have this notation AX2E2.
Is that it?
Lewis structures are a graphic representation of the electron distribution around atoms. Step 1. Find the total number of valence electrons by adding up the total number of valence electrons from all the atoms in the molecule. Step 2. Find number of electrons needed to make the atoms happy. Atoms is considered happy if the atom's outer electron shell is filled. Elements up to 4 need 8 electrons to fill their outer electron shell. This is the property known as the octet rule. Step 3. Determine the number of bends in the molecule. Now you need to subtract step 1 and step 2 to give you the number of electrons needed to complete the octets. Step 4. Choose a central atom. It is usually the least electronegative or the atom with the highest valence. Step 5. Draw a skeletal structure. Connect the atom to the central atom with a straight line representing a bond between the two atoms. The central atom can have up to 4 other atoms connected to it. Step 6. Place electrons around the outside atoms. Complete octets around each of the outer atoms. Final step. Place remaining electrons around the central atom. Complete the octet for the central atom with the remaining electrons if there are any bonds left outer from step 3.
Go.
Oh, hey, I didn't see you there. I'm going to talk to you guys about bonding with atoms. Now you see, according to my notes, ionic bonds have a high melting point. They're very strong, so it will take a lot of energy to break them. And they're pretty conductive, while covalent bonds are polar opposites. Polar. They have a low melting point. They're brittle solids, and they are a lot weaker than ionic bonds. A couple other bonds are dipoles. Dipoles are an unequal sharing of electrons. So one atom is less or more electronegative than the other, which causes for an unequal balance. There are hydrogen bonds, which are specific bonds between hydrogen and another atom. And there are London forces. All atoms go through this stage. It's kind of like a dipole, except it's different in some ways. The octet rule. The octet rule is the octet rule is that most atoms want to have the 8 valence electrons, but there's an exception to this rule. As you can see here, boron is fine with 6 electrons. He's a happy atom. But if you come down here to carbon, he needs all 8 because he's greedy and will not settle for less.